Hello, everyone, and welcome to Chapter 4, Section 5. So, this time we are talking about some cool types of graphs. So, we'll have some pictures to draw, but we'll take it step by step. We'll work through these and understand these concepts. So, we're moving away from equations, and now we're going to look at some lines and some plots of some data. So, we worked on all kinds of equations in the past. This time we're going to investigate the relationship between some different kinds of points. We'll call those scatter plots, and we'll see that coming up. We'll use some lines of fit as well, and we'll talk about that as we evaluate our graphs. So we'll look at different types of data. This word bivariate, bi prefix meaning two, variate meaning variable. So bivariate means two variables. So those two variables, typically x and y. We'll look at that. We'll have our scatter plot where we plot several points. We'll draw a line of fit on the plot, and then we'll be able to make some predictions about what will happen in the future. So this is the big concept for this section. We have different kinds of correlations. So as we look, we have a positive correlation, and that means our data go up to the right. As x increases, so does y. They are positively correlated. Now our negative correlation, as x increases, y decreases. In other words, we see our data trend down to the right. So positive goes up, negative goes down. Now no correlation means there's no real pattern. It just seems random. There's no real pattern going up or down. So that's no correlation. So positive going up, negative going down, no correlation, just scattered. Now, we're going to look at several of these examples. There's going to be a bunch of words. So what I need you to have is the picture of a graph for each of these examples. So we're going to want to draw these graphs, plot those points, and make it as accurate as you can, although it does not need to be exact. We do want to just make sure we have the trend, and we'll label the axes correctly. So please begin doing that as we talk about the context here. So the graph we see at the right, what is going on here? Well, it shows the average number of students per computer in Maria's school. So students per computer, we see that right here. We see the years going by on the x-axis. So we want to see, is there a positive, negative, or no correlation between all of this data? And we want to describe what that means. So as the years go by, as the years increase, is there a pattern in the number of students per computer at this school? Well, we see as the years go by, what's happening to the number of students per computer? They're going down. And since they're going down over time, we see a clear trend. As the years go up, students per computer goes down. So our answer should say, we see what kind of a correlation? Well, it goes down and to the right. That is a negative correlation. In terms of the context of this problem, when they ask us to describe what it means, we know it means every year more computers are in Maria's school, making the students per computer rate smaller. So every year the number of students per computer goes down, and we can explain that because there's more computers that they're adding to the school. The key here is just knowing that it says this is indeed a negative correlation. Negative. So have this trend of dots going down with years on the x, students per computer on the y, and we have a negative correlation. So that is 1A for this one. So here's another example. We want to identify what kind of relationship do we have here, if any. So please plot these points for 1B. You have years on the x and number of prescriptions on the y, so label those. And just plot your points going up this way. We don't need the numbers to be exact. We just need to understand the trend, okay? So 1B. This graph shows us the number of mail order prescriptions. We can determine whether the graph shows a positive, negative, or no correlation. So let's think about what the data are doing. As the years go up, so as we move to the right on our graph, what's happening to the number of prescriptions? Well, as the years go up, the number of prescriptions also go up. So they are positively correlated. As the years go up, so do the prescriptions. So, what do we know in this case? We know our trend is going up. We look at our dots are going up to the right. So we know this is in fact a positive correlation. The variables increase together. As the years go by, the prescriptions also increase. So they are positively correlated. So for 1B, have the years going up, prescriptions on the Y, plot those points, and we know this is a positive relationship. They are positively correlated. And we confirm with our red circle. So as we're working through these, we're going to need to make sure we have those pictures. We're going to say positive, negative, or no correlation. So, one thing to think about. When you see all of these data points plotted and there's no line connecting them, we call that a scatter plot. So there are several points plotted together. Now we want to determine if there's any relationship between them. We draw a line that passes close to the data points. This is going to be what we call our line of fit, and we'll see that coming up. We could use 2 points on that line of fit to write an equation, and we'll see these steps in the problems as we work through them. So, 2A, we see a table. It shows the population as we go up. So don't worry about the table yet, but we are going to draw a graph coming up. So for 2A, we see the table shows the population growing at a rapid rate. So as the years go by, the population also increases. So we can identify the variables and make a plot, and then we'll talk about how they're related. So, what do we know? Well, the years, time is always our x. The population, though, that is always our y variable. So we can label those. Now to make our plot, then we have to use the points given, and we'll start to understand it. So don't worry about the table, but we will have this plot down. So first step, we would plot any data that you're given. So the independent variable is always x. In this case, that's years. The dependent is your y. That's the population. So as the years go up, so does the population. So we see a positive correlation. As one increases, so does the other. So if we plot those points, we get this graph. Now this is the piece I want you to have. You have years on the x, population on the y. You don't need the exact numbers, but do plot the points with the trend, okay? We need to have that. And we can now try to describe and understand this relationship. So, what do we notice here? As the years increase, as the x's, in other words, go up, our population also increases. So the population, that is y, our y's also increase. So as x's go up, so do the y's. So how are our variables related to each other? Well, as one increases, so does the other. So they are positively correlated. They do the same thing. As x goes up to the right, so does the population. And we see the trend of our data going up consistently. So that's where we get this. And that's the key for this section, positive correlation. So we have that. We need to make sure we have the trend of these points on this image for that step. So once we have our points drawn, we understand the relationship. Now we can try to draw a line of fit. So this line of fit term means you want to draw a line that's close to most of the points. You should have a few points above, a few points below, but the line is very close to most of them. Now the line of fit allows us to make predictions that are close to the trend of the data. So we want to draw a line close to most of the points. So it should look something like this for these data. Now when you're drawing the line of fit, notice it has to be a straight line, and our plots in real-world data will never be perfect. So no one line will pass through all of the data points. So we draw a line, it just needs to be close to most of them. So here's an example of that. Notice there's points on the left and the right, but our line goes through most of them. It shows the general trend. So next step, so make sure you just draw that line, add that to your graph. Now the next step here, we would want to actually know the equation for the line we just drew. So we can write that in slope-intercept form. So we would get 2 points that the line goes through. So in this case, we have these numbers here. So this piece I also need you to have down, these 2 data points. Now we're going to plug these in and solve for our slope. So our slope we know is change in y over change in x. We know this very well. So we have our x's and our y's in these 2 points. So we can now subtract the y's and the x's, find our slope, and get closer to getting that equation. So what is our slope? Use that formula, find the differences. Difference in our y's, notice that here. Difference in our x's, bam, bam. Just subtract those and divide, and we get that final slope. So we can simplify this one more time. So have this final value that we're about to get, have the starting points, and our final value on the next slide. Our slope is in fact going to be that 5,400 over 154. Now you could use a decimal version of that if you'd like, but this fraction is going to help us as well to get our final equation. This doesn't come out to a whole number. Now, we can use either point that we had and use the point slope form to get our final equation. So we can have an x and a y from a point we take, and our m value will plug in this big fraction here, and then that'll allow us to get our final equation. So plug in the 3 things that we know we can substitute in here. M, our x, and our y. So x and a y taken from a point. This is our m value. And now we need to just simplify that to get this in slope-intercept form. Because notice, we're asked to write that in this form here. So what do? We distribute this fraction to the x and this number. We would get these 2 numbers here. And then one more step, get rid of this 1,000 by adding. So we do that, and y is about 35.1x minus this big number here. The value of that is we can then use this equation to make some predictions about our data in the future. So we need to have this equation down as a part of this real-world example 2 problem. Y is about 35.1x minus 63,870. So it's several steps, but we're working through it, we're understanding, we're attempting it and trying to get these concepts. So there's our equation of that line. So in future problems, you'll have to do similar steps. So here's another one to look at. This table shows the number of bachelor's degrees received since 1998. We're asked to draw a plot and determine what relationship would exist. So we can draw a rough sketch here, and please do this with me as we attempt to understand what correlation there is. So years is going to be my x, degrees received will be my y. So I'll put years on the x here, and I'll put degrees on the right. So this is degrees up here. Now the years since 1998, we see we're going from about 2 to 10. So I have 10 here and 2 over here. We're going to increase by 2 each time. Now on the degrees received, I see I start at about 1,000, go up to close to 1,200. So I'll just put 1,000 here, 1,100, and 1,200 up top. Give us our rough sketch of these numbers. So now we can just generally plot these points. So at year 2, we're looking at a little more than 1,000. At year 4, we're at 1,136. At year 6, we're at 1,169, so a little bit more. At year 8, we've dropped down just slightly at 1,165. And at year 10, we're at 1,184, so the biggest we've ever gotten, just a little bit below 1,200. So with all these points given, we can now attempt to understand what, if any, is the correlation. Is it a positive? Is it a negative? Or does it look like there's no relationship with the degrees earned over time? Does it look like there's a trend in some direction? Well, it looks to me that as the years are going by, these points are generally trending upwards. We see this looks like a direction is going up to the right. So this would be a positive correlation. Positive correlations go up. So looking at this says negative, this says none. We can determine it. This is definitely a positive correlation. As the time goes by, people are earning more degrees. And that makes sense because we live in a more competitive market. People have to get educated in order to have a chance to make higher money. People are motivated to go to college to make more money. So for this one, it should be A, positive correlation. So we can confirm with our circle there, and notice this is the more exact version of that graph. As long as you have an image with that trend going up, that is what we're looking for. Now, if we're asked to draw a line of fit for that same group of data, so we're going to add one more line to the graph you already drew, how do we do that? Well, we know a line of fit should follow the trend. So if our data went up to the right, our line of fit should also go up to the right. So anything that's not doing that should be wrong. Notice C is flat, that's not correct. A is going down for some reason, that is not at all following the data. So what else do we know about lines of fit? Well, a line of fit should also just be a straight line. It's not allowed to bend or break or turn. So if we look at B and D, while D follows the data closely, this is not in fact one line. We're looking at 3 different segments here combined. So D is out because this is not a line. We have a curving segment with 3 different spots here. That's not correct. So which one is the correct trend of the data? Definitely B. It goes through most of the points. You have one above, one below. That is exactly what we're looking for. So draw your line just like this through your data. Add that to our notes. And we confirm there with our circle. Now the last step would be to find out what is the equation of that line that we just drew. So what do we know about this line that we just drew here? Well, it looks like it's intersecting that y-axis at or very near 1100. So it might be slightly above 1100, but we know it's very close to that. And if we go back to our data points, we can tell it should be pretty close to this 1050 number. So it should be close to that, a little bit above it. So if we intersect there, our y-intercept looks like it's about at 1100. And we also know this is a positive slope, right? Because positive slopes go up to the right. So this goes up to the right, it has a positive slope. In other words, the number attached to x in our lines, the number attached to x has to be positive. So anything with a negative number we know is wrong. So B is out here because our line is positively sloped. Now we said we know our intercept was at 1100 or very close to it. So this one has a y-intercept of 47. That can't be right because that intersect would be way lower than what we saw. So we see A and D left. Now those two are very similar, but we see one has a higher intercept than the other. So if we look at our graph and we make it as accurate as possible, the answer is actually just a hair above 1100. So that equation should be y equals 8x add 1104. That is the equation of that line. So we were adding together all the concepts we talked about to get that equation and work through these problems. Now here's a third type of example to think about. In this table and graph, we see we're talking about the population growing over time. So don't worry about all this going on. Just draw yourself an image of this graph with a line of fit with years and population up here. So we want to use the equation given here and make a prediction about what the population might be in the future in the year 2025. So the value of these equations is that we can plug in any time for x and have a rough estimate of what we think might happen. So we can make a prediction about the year 2020, 2025, any year we want by just plugging in that year for x. So that's what we're going to do in the next step using this equation. So you have a general picture with the dots going up, with a line going up as well. And we'll use this equation on our next step. So we want to plug in that year for x that we're told. So there's our equation given. We'll plug in that value for x. Now we're simply just multiplying and subtracting. So multiply here. You get this big number here, a little over 70,000. Subtract that 63,000, and our y value is 7,207.5. So what does that mean in terms of this problem? Well, that is the population that we expect to have in the year 2025. Now, this kind of thing is useful because understanding what the population might be in the future is beneficial for understanding how much resources we have as a community, as a country, economic things to understand about how much money we're spending, what do we need in the future. So these kind of predictions are done daily and are very important to the survival of people in all over the world in different economies. So we have this number down for millions of people in the year 2025. Now here's a part B problem of a similar type. So draw yourself an image here with the points and upward line of fit. We see x is years again since 1988. Our y is the degrees received. We're talking about bachelor's degrees. That means after you've gone to college for 4 years. So we're going to use a table and graph to understand how these degrees are changing over time. So please have this picture down as we move forward in this problem. Just draw your points, a line of fit. You have a point above, a point below. Label those axes. So we'll use this context. So say the equation for the line given there is this equation here. That's the equation of that line of fit. If they say x is years since 1988, we know that, and y is degrees earned, we can predict how many degrees might be earned in 2015. So in order to get that number, we must plug in the correct number for x into our equation. So we know y equals 8x plus this number here. But what is x? What is this value? Well, x is years after or since 1988. So then my question to you is, how many years after 1988 is 2015? Well, in order to get there, you would have to subtract here. If we do that, we would get 27 years. So given this is 27, that's actually what we plug in for x here. So y will equal 8 times 27. We'll get a big number there, and then we'll add this number here. 1104. And the number we get here will be in thousands. So we'll have to add 3 zeros to that number. So if you multiplied here and added this number, the value you would actually get would be 1.32 million degrees earned. So that is our solution. That is it for 3C. So please have that number and just that equation down for this example. 1,320,000. So given all of that, hopefully we feel confident as we jump into some